Hey, well, here we are, Ken. Another ZD TV day. It's exciting.
Hello,
We
friend.
don't. Oh, hello. We don't do them every single week, although we do try to do them every single week. Sometimes it's not so obvious as to what we're going to talk about, but today we have something special, don't we, Ken?
I'm excited.
Yeah, we have special guest star Andrew Martinez. He's going to come in and he's going to talk about Go and generics, and specifically what generics are, what they're all about, how they might impact Ziti. So let's bring him onto the stage here. Boom. Hello, Andrew.
Hello, how are you guys doing?
We are great.
Yeah, doing good.
So, thanks for showing up. Like I said at the intro, we're going to take a look a little bit about Go generics, and then maybe look at some code and see what they look like inside of OpenZiti, where they are in OpenZiti. If anybody wants to come and see what exactly we're talking about, they can play along with the home game and go check the code out. But for people who might not know what a generic is, Andrew was asking ahead of time, "Hey, are we gonna, give an overview of what generics actually are?" And I said, "Boy, that's a really good idea, Andrew. We should do that." So, I've used generics in other languages. C Sharp has generics. Java has generics. I've not done any C++, but I think they have generics now too, right? I don't keep up with that. But anyway, what in your words, Andrew, what is a generic?
Oh, uh, the easiest way I think, if you've never used them before, it's to think about code as it becomes a template where the types don't matter. The types can vary between instantiations of functions, which might not make sense when you first think about it. But if you consider if you've ever had to copy a function and just change the type because that's the only thing that changed, that's a great use for a generic because
And
you're
And do you have to do that a lot in Go?
right now, yes. Yes. In Go right now, you have basically you have a couple of options when you have a function that you want to reuse across types. Um, the kind of the path that was laid out was interfaces, and they if everything can just be an interface, everything will be great, and you don't need generics, which is true. However, there are scenarios where you have um, you have situations where the interface isn't enough. You have code that's instantiating multiple different types, and it's always done in the same way. Like an interface can do that, but you have to jump through a lot of hoops. And generally, what happens when you get to the point where you have to deal with something and you don't know what the type is, and you want to instantiate a value of it, you basically use reflection, which is slow. It's also, if you're not used to reading it, it can be cumbersome. It's also kind of difficult to debug. Like there's a lot of nuance involved when you start doing reflection, and especially in Go, where you have to deal with things where you may have a pointer type, not just a concrete type. You have to, you have to deal with those complexities inside of your code. And there's also some sharp edges if you're dealing with things like lists, slices, or arrays. If you're not a Go programmer, they're called slices in Go. Um, and the other option is to pass things in as just a special data type called interface, which basically just munges everything together. And it's not super great because you have to do a lot of type assertions in order to figure out what type you're working with. If you need to actually call any actual functions or access any properties on the underlying data types, and those have those paths have kind of been the standard go-to tools that we have. It also forces you into scenarios where you have to use composition quite heavily, and you have to use a lot of function pointers in order to kind of push the types out of your generic code and deal with all the complexity at your lower levels, which it does work. It just means that in some scenarios you end up copying functions over and over to do the same work where you could have just used a generic.
That's the
Um,
worst.
it's pretty unfortunate, and so kind of one of my patterns inside of when I'm working on Ziti is, say we need a new in the edge we have an unfortunate name. It's called a router, but what it really is, it's an API router. So basically, what it
Now,
does is
router is a common term across other APIs, right? So, like, it's not something that we invented.
no, it's called like a route handler. So that's normally what it's called in the underlying Go lingo for HTTP servers.
So it's
So there's
routing
this,
function calls as
yeah.
opposed to
So
network payload.
It's like
yeah,
matching
it
up
is not
a URL path to some logic.
function. Yeah, pretty much. And so they're called routers inside of the edge. Um, and kind of if you want to show my screen, I actually
Yep.
have one pulled
Let's
up here.
let's take it in. Oof, right here. Let's
Right. So we're actually inside of this is going to be inside of OpenZiti Edge controller internal routes, and uh, the main thing that we're looking at here is like basically when I write a new router, I come to this one because it's one of the simplest ones we have, and I copy all of this code and I paste it
oof.
because
Yeah, but you feel
the
good when you do that.
I feel
Feel
good
like
every time,
feel like
and
you're
then
doing a really good work.
I do. And then I just find CA matched by case because it's always a capital C and a capital A. And then I replace them
Replace.
all with them all. And a lot of this code in here is it's very generic. So there's a delete, there's a detail, there's a list. This is all in the management API. And so
So if I can
there's a couple,
understand here, this is routing a URL to a function, and that's why it's called a router. And because we have this boilerplate code and we don't have any better way to handle it, we've had to copy paste the code to deal with that. Is that what
yes,
I'm yeah.
that is, there's actually even it even goes deeper than that. So this a lot of
Ooh.
this code that is all of these types, this is generated from the Swagger spec that defines the Edge's management API. So this is all generated too. And since they don't have generics there, they also have a similar problem where they basically just expose all these different types to you and they just say arrange them in the correct order. So they don't even have generics to help us because a lot of these handlers are basically they all take the same arguments and like their code honestly doesn't care what it does.
Do they
But
take the
like
same arguments? Like, would we need to copy and
it's
paste
the
if it took
same it's the same types of argument. Well, oh, let me clarify my language. It's the same kind of arguments. It's actually different types inside of the code that's generated.
Right.
But realistically, nothing changes. Like each of these statements is exactly the same
The only
every
thing that
time.
changes is the actual type of
Yes.
yeah,
And it
makes
it
sense.
feels it it and that's kind of the standard go path is like when you're especially when you're dealing with generated code you don't have a lot of options. So for this one we have our this is basically a CRUD endpoint: create, update, read, and delete, and that's it. And none of these change. This section, the only thing that changes are these types, and I copy this thing every time. The generics, we could just have a CRUD type, and basically all of this code would be abstracted away inside of a generic, and it would be great.
Cool.
um,
Are we going to be able to see some semblance of that maybe?
We will give it a go. I don't have Go 118 Beta 2 installed on this machine, my normal work machine. So
Yeah,
the
we can
editor
just
will
get
most
close
likely
enough.
complain. We
Yeah,
could get close enough.
yeah, I just really wanna see how you like, 'cause I haven't done a tremendous amount where I've needed and I went, "Man, I really, really wish I had a generic here." I've used like I said, I used them before, so I know when I would use them, but I haven't
Yeah.
seen how we would use them, and that's what even if we just have to kinda, get close enough, that's cool.
Yeah. And we can to make it a little clearer, like actually show what a generic is. So this is actually on the if you actually go to the GoLang website, you can actually look at the proposal for generics, and that's what I pulled up here. They also do have the 18 release notes up, which also have some information as well. If you just go to the GoLang website, you can it's all at the top. You can just click on it and find it. Um, but this is how. So there's kind of two types. There's going to be um, you can use generics inside of function declarations, and then you can also use them for types for actual your own structs that you would create in Go. But they're doing a couple things. One, they're using brackets to section off their type definitions for or what they call type parameters. And so this T is actually the type parameter, and this thing on the right is actually the constraint.
Do
So
you need constraints? Are those required?
no, you can actually see an example down here. You can use any, which just basically is syntactical sugar for interface. If you're familiar with Go, if you're
And
not
you
familiar with
must
Go,
specify any?
yes. As
Mm.
far as I know, I think if you leave it off, maybe it'll default. But I've never seen an example because this one right here is T1 comma T2, and they're both using any um, in this one. But essentially, any just means any type. It does influence what you can do with your types, because your types will essentially be uh, the 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 minimal shared set of capabilities that those types can do together. So if you have an any, you're not going to be able to do call any methods on top of your types, because the empty interface by definition in Go doesn't have any types, or it doesn't have
Right.
any methods. But this is an example of a function one. So what we're trying to do here is restrict it to stringer, which is a custom interface they have defined here, and essentially they're just merging them together. As long as it's a stringer and it has a string function essentially, we're basically can work with it inside of this generic function. So
Can I make sure I'm grasping the basics here? The at the highest level, Go is a typed language, and this is a way of handling the ambiguity of a type for some value. Correct?
yeah,
Would you say it's
that is
handling ambiguity? I would say it specifically takes the ambiguity out of the equation entirely. You must
w-
have a type that is of one of the ones specified by the constraint.
yeah. Let me jump over back into the code, because there's actually a another another thing that we use inside of
Ooh, can you make that
Ziti.
bigger?
Yes, 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 I can. So this is concurrent map, and concurrent map is Go comes with sync.map, which is also another form of a map that is essentially Go routine safe, or if we were in a different language, we would say thread safe. And the reason you need thread safety, if you're not familiar with this, is that if you have two different execution lines all accessing the same map at the same time, if one is removing values and one's putting values in, they are not going to have a shared reality. And in some scenarios, that might be okay. And in other scenarios, that could be extremely bad, because values could disappear, especially if you were iterating over a collection, or you were working with a key and you expect it to still be there, and you go to access this and it's now gone. So usually what happens is you're using some kind of map beyond just the built-in map type that can essentially handle the locking of the map itself, so that only one person is mutating it at a time. It's common, in a lot of thread safe libraries, to have multiple readers is fine, but only one mutator. So the second someone mutates, it locks the whole thing down, and then you have a couple options. You can stop reads, or you can create a shadow set where the read is getting basically the previous version or the previous view of whatever the data collection was, and then the mutator is mutating, and once they're done, it then gets the next time people go back to read, they'll see the new one. There's a
And
couple different
and so
strategies there.
right now, if anybody is using ZD code and they wanted to use concurrent map shared, they would be forced to use a key, which is a string, and then they could put any type that they want as the value, right? Because the
Yeah.
map itself has a string as the key and interface as its value.
Yeah. So it's right. It basically comes down to this: is that they have a map, an internal map that they're actually using for the current state of what's being written to. It's a little more complex than this if we go a little bit deeper, because they do have this concept of sharding. But at the level, this is what we really care about. There's a map and it has interfaces in it. And the second you stick anything in there, it can be anything. It's not type safe. There's nothing stopping somebody from putting the wrong type in there. So if you actually go into a place where we use this, so we're actually using concurrent map here, and it basically, we call new, we have it, and when we're adding things, we can get them by a key, but when they come out, you then have this pattern that usually happens. It basically says, okay, we get this thing out and it's going to be an interface, because if we actually take a look at this get, it's going to come back out as an interface. So there's no type safety here. So then the second thing we have to do is we have to check. And we do this using a type assertion. So it's this period and then this. You would call it casting in other languages. In Go, they call it type assertion. And basically, type assertion returns two values. Did it work? And then a value. Um,
And
you get
status
to,
would be of that type.
it would be of, the status would be of type pointer status, a pointer
Yeah.
to a status. You get both out, because you don't know, since this is a pointer, nil might have been stored in there, so nil might be the correct value, and that might mean something to your code. Okay, will tell you if the uh, the the nil value in there was of type pointer to status. So in Go, nil can be type safe. if that makes sense to you.
That makes
Um,
sense to me. Yeah.
so you get these two values out, and then there's this generally okay, and then there's do something with it. In this one, we're just checking to see if it's been expired. In other cases, you might, if you get a type that you're not expecting, you have to decide what to do. Do you panic? Do you fatal? Do you log a message? Like, what do you do? Because at that point, it most likely means programmer error. But this
And
is if
so
you're in a
yeah, oh, go ahead. Yeah.
yeah. So if it's programmer error, but the question is, you can't write tests for programmer error, right? Under most circumstances, unless
I
you
suppose you
instance.
could, but it's prohibitively expensive to go write them for every programmer error because you'll never find everyone and cover all the cases.
That's correct. So the other thing is that if I come in here and I see this, if I see concurrent map, this tells me nothing about what's supposed to be here. I can guess. I
Yeah.
can say, oh, it's probably an identity, and
Hopefully.
it's probably the identity ID. But it could, if this is some cache where it's doing some kind of advanced mapping or sharding or doing something like hashing to get a key where the essentially the key into the map is more significant than just an ID. There's nothing that tells me what it is.
Feels like
Like
the
there's
evil days of using a dynamic language. Ooh,
yeah,
no types.
yeah,
Ooh,
no types.
scary.
So usually what we do is we put a comment after it just to say what it's supposed to be.
Oh,
And then hopefully it's not wrong or doesn't change because
well, right.
that can't
So
happen.
you could refactor this and easily miss that comment.
That's right.
And then you
So,
won't find out until you until you do the type assertion and then you return
yeah,
false.
yeah. So not having generics, especially for collections, it basically it makes your code type unsafe, and then you have to go through all of these hoops to make it type safe again. And
Mm,
hopefully nothing gets messed up along the way. Hopefully your unit tests cover it. Hopefully
mm,
your API and integration tests cover it. And if somebody happens to do it wrong, they might not, depending on what you do when you're actually checking your types when things are being worked with, when we're doing our type assertions, they might not raise any problems. It might just ignore that thing.
mm,
And that might be a bug. That might be fine. It might, who knows? It depends completely on the implementation. And I can tell you that this is a very simple just type assertion. Just ignore it. Return it or just return false. That might be fine. But you really have to think about where you are and what you're doing. So if we did have generics, if we actually were running Go, we would actually be able to do something like this. So if this is concurrent map, um, we might be able to do string, and then this was actually an identity. Oh no, this was a status. So status. So you can't actually do pointers in this first iteration of GoLang. Like you can't
oh,
you have to do it like this. If you can't do it on a concrete type, if we had an interface just called status, it would work just fine because it's a weird restriction on their first implementation.
hmm. Makes me
So if we
wonder
had
what the
some,
decision was behind it. Like, why?
In Python, there's something
uh,
called a parameterized generic, which would be like saying it should be a list, but the elements should be of type string or integer or whatever. Is there something like that in play here?
That's exactly what he's just done. Yeah.
yeah, and so yeah, it's basically it says in this one the concurrent map. This would be the string, and this would be the status. Or and status would be the values. If we wanted to make it fancier, we could also do something like this. We could do, I call it type aliasing, but it's I don't know the right word for it in Go. Type aliasing, type subbing, but we could also do like identity ID string like
Hmm.
this. We could basically just say identity ID is a string.
Hmm.
Um, and so
That's
this
nice.
would
It conveys a little bit more information.
it does. It also allows you to do things in Go. It also allows you to do things like put a method on here where now if something is actually cast as an identity, it actually has my method on it. Like you could do something like stringer, you know. But in this implementation, it would just return itself.
Yeah. Neat.
But but so yeah, so if we had this one, it would get rid of this comment. Two, this would now be strongly typed, and it would get rid of this. It would get rid of this val, and instead it would just be status, because we would either we'd either have the status or not. So we'll get rid of this.
Right. I was gonna ask you what the difference would look like. Cool.
Yeah, which would be extremely nice.
It's a lot less
But
code. 2 extra lines gone right there.
it's actually, yeah,
And
and it's,
and information conveyed.
yeah, it's also, it enforces type safety, compilation errors, and a whole bunch of things come with it. But we don't have it, so, at this
Not
point in
yet.
time.
Not yet.
Not yet. It's
Soon.
beta 2 soon.
Soon.
Yeah.
I
So
wonder, has anybody put, an issue into GitHub to migrate to 1.18/generics, or is it just so interesting to you that you're like, "As soon as this comes out, I'm just gonna go do it."
it's going to be opportunistic. So a lot of this code in here, it works just fine. There's no
Mm.
reason to just go refactor things for the sake of refactoring them. But opportunistic refactoring as you go through an area, especially if you can improve it, or you want to add tests and writing the tests, it's working with like an interface based concurrent map makes it difficult. um, it would definitely be something that I would probably just do.
Not to mention, as
um,
soon as you change this one, CMap.concurrent type, if when you change the actual, uh, map itself to be generic, it would splinter through the entire code base, and that would be one gigantic PR.
yeah. And so we can also take the same constants of like this concurrent map, and you can also think about more advanced types of collections. So caches kind of fall into this category. So this is like just using a concurrent map is like it's a thread safe way of creating a cache of something. And so if we can put a generic on here, that's great. But we can also do type based. Um, we can also do type based generics as well. And what that will allow us to do is it'll allow us to create types that are of themselves generics.
Mm.
So like this type vector t any is an array of t. So like this is just like a generic, like vectors have been around on a lot of programming languages. So basically, just this is just a typed array of this of any, which
And
is fine.
you often, I think, see a vector or a list or whatever used as like a collection is almost always the thing that people go to first, right? Like it just makes
Yes.
sense. Like you said, a cache, everybody does it. But it is incredibly useful in other places. Like I already can see one place in our code base where I would use a type or a generic as they would be called. But I don't want to steal any of your thunder, so I'm going to let you keep going, and we'll see if
Yeah.
we come to the same conclusion.
Yeah. So there's also advanced types of collections that actually have behaviors, but you do the same behavior regardless of the underlying type. Maybe it has to implement a specific interface. So this is another example. This is a generic where we have an edge where it's any, and I believe this is a graph or shortest path solution. And so you can actually have referencing types. So you can actually create a type. You can have generic methods that are also generic for this generic type. And so basically what you end up doing is instead you get type safety on these really complex. So we're talking B trees, we're talking about N trees, directed graphs, um, and then kind of outside of that, something I was touching on before, sequencers, which use trees underneath them. Like we use sequencers inside of Ziti in a lot of different places just to sequence messages, and those are type safe on their own usually because we write them for a specific, are the way we're sequencing packets at Ziti packets uh, inside. Uh, but we also have situations where we've literally just copied that code because we needed a sequencer somewhere else. So instead of doing that, we could just have one generic sequencer, or we could have sequencers with like different behavior properties that we want, or maybe they're configurable. And instead of having multiple versions of it, we could just have one. So this is stuff that we would take probably from the fabric and maybe the edge, and we could push them down into our foundation library, and we could just all be using the same configurable tree, or maybe purpose built trees for sequencers, which would be really cool because then we don't have to copy that code every time we want to use it for a different type. uh, so so
How
so
how
the
often when we copy code do we have to go find all the places that we copied it and update it?
usually when you do it, you're trying to build it for a new type, so you copy the code and you are changing the types, and you're also probably changing the name. And what that does is it creates a new type that no one's referencing, and since you're creating it usually for a purpose, you're the first person to use it. Um,
So not
and
not usually a problem then, that's what it sounds.
no, it's not usually a problem in terms of confusion. It's just, oh, I'm copying this thing and moving it. The other option is to use interface, and in those scenarios, you got to do your own type assertions to make sure everything's okay.
Have we
So
have we had to refactor something yet and then have it splinter through all the copy pasted code where it was a real pain? Couldn't find it all, maybe had a bug from it?
um, I don't think I can't come up with any bugs off the top of my head, but it has happened where we changed a type in a lower level, and then we had to go to all the upper levels, like in Edge and Fabric, and refactor them because we either changed the interface or something. But I don't think that's not something generics are going to solve.
Yeah, yeah.
That's just a general programmer that has to go do it type of scenario. Um, so we get another thing that's interesting about Go generics is these any type, which I did talk about before. It's basically syntactical sugar. It basically stands for interface. I said that before. It is interesting because they did add some other sugar type stuff. So they added this new constraints package, which is going to have uh, predefined constraints. So one thing that is kind of
Oh,
cool and
that's
interesting
useful.
is that constraints inside of Go are actually just interfaces. So you can define them in line, um, much like we were doing in here. You can. This is actually creating an actual interface for this constraint on type parameters. It's just doing it in line, but you can also name them separately, which is very nice.
Oh, and then you can
Um,
just reference the name. Oh, neat.
Yeah, so, like, there's actually
Oh, so
here
you
we're
could add a whole bunch of them. Oh, I get it. Oh, neat.
yeah, so you can actually this is creates a union of types, so
Yeah.
there's this is complex is now a constraint that you can use in any of your generic functions or generic types,
Oh, boy.
and this tilde operator, we'll get into this in a second, but I just wanna
I bet
cover
there'll be
this.
one that's called number. Where's the number one? Signed,
Um,
unsigned. Nice.
Signed, yeah, they have a whole bunch of them, and so they're built in, and the thing is that when you use the built-in types like int, those can all use um, the comparative operators. So that's equals, not equals, less than, greater than, all those. And so actually, if you when you're using signed, whenever you have these types, you can actually still use those operators. So Go doesn't have a way to overload operators or implement comparative operators on top of your own types. You have to just name a method and come up with your own convention of doing that. But specifically when you're using the built-in types like this, um, the minimum set of functionality you get is basically all of the Go language that can work over your primitive int types, which is kind of nice. If you wanted to throw in your own type in here, like you wanted to call my number, and it's a special way of storing maybe a bigger number or numbers with specific properties you care about that you need to access very quickly, you would lose access to the built-in comparator operations. They did add in their spec, they did talk about adding comparable, and there's a way to make it so that you can use at least equals and not equals, but the other operators are left out of that.
I wonder why they left like, I don't see any number in here. I see signed and unsigned. I wanted to see number.
It's funny because in a lot of the examples out there, they somebody creates a type number and they add every
Signed
type
and
of number,
unsigned, right? Yeah.
everything, and
It just
and
seems so
they
obvious, really.
yeah, it does. And I don't know why it's not in this spec. I think in the actual proposal, I think there was a number, but I might
All I
be
know is there's
misremembering.
always a reason, right? Like, I'm old enough to know that there's always a reason somebody didn't do something obvious, and I just wanna know the reason. I can't imagine it was an
Um,
airball.
no, I think they're trying to keep Go simple. And the second you start adding operator overloads, it makes your code slightly less readable. And by slightly, I mean greatly. Because if you see a plus operator, you expect it to be string in Go right now, you expect it to either um, add the values together or concatenate them with strings. But if somebody overloads the plus operator to do some other type of weird thing, right? like that you would never expect. Maybe it, instead of it concatenates the strings in reverse order. You, when you're reading the code, it doesn't make sense to you. Like, it's not plainly obvious until you go and look at the what plus operator is being executed, and you go look at it. So in order to make any type be able to use those type of operators, you would have to expose the ability to define that behavior. And the second you do that, I think it's where you start leading down the path of more unreadable code. And Go is trying to be as readable as possible. And
So
so
now,
that kind of meta programming is waylaid with those decisions.
now I feel like I learned something I did not know. Are you telling me that Go allows operator overloading? I've never looked into that.
It does not.
Oh, okay. Okay. Gotcha.
It does not. And it would need to do that in order to make it so you could
I
access, like,
see. Now I understand what you're saying. All right, cool.
yeah, since it doesn't allow you to do operator overloading or redefining operator um, semantics, you can't expose them in generic methods for use unless all of the types happen to support it, like
Gotcha.
complex or all of these int values. Like, if you use signed, like say you created T1, T2, T3, and they were all signed, you could add them, you could subtract them, you could do greater than, less than, you could use all those operations because the minimum set of capabilities they share is all of those.
And are you so I know we were going to talk about the tilde. Is that tilde going to somehow tell me about how the bytes work when I try to add, say, an int to an int64 or an int64 to an int?
No,
Darn.
the tilde is interesting. So I showed I showed it before, inside of the I showed it inside of I showed it inside of with type aliasing. Basically, what the tilde means is that if you alias int16 to be like my int16 and you add some methods on it, it allows your my int16 to be used as int16. It's basically type approximation. You are When we look at your underlying type, you are actually an int16. Even though you're called a different name and you have a
Mm.
bunch of methods, you are still an int16, and therefore we can treat you as an int16 when we come in here. So this is, if you do my int, right,
Yep.
it will count as int tilde when it goes into, the
I
generic
see.
function.
Now, however, if you were to reference stringable signed integer, in this case, we know it'll have string on it because it's defined that function there.
Yep.
If it didn't, if my int had a function on it, but none of the other was one did, and it wasn't in the stringable signed integer, you wouldn't be able to access that function, right? So if there
Correct.
was, yeah, okay, yep,
Yeah, it's the
makes
minimum
sense,
set of supported methods, and it
makes
just so
sense.
happens that
And
they
it
all support it. So,
and Go will just figure that out for me, right? Like it will find all the functions defined on all the types and present me the synthesis. I don't have to
yep.
define them under a certain interface.
No, it'll figure that all out, and it'll throw compile time errors if you try to do stuff that's not supported by a type. So,
Neato. I wanna try
yeah.
that.
There is this issue though. It is technically possible to create an interface where no type can satisfy it. It's called creating an empty typeset. It's you cannot. There is no way to satisfy this because nothing will ever support all of these things because I can't. I think it's yeah. It They call them empty sets. It's interesting. It's just that you can create a constraint that it cannot be satisfied by any types in your code, and therefore nothing you even though you're specifying types in your generic function, you can't actually do anything. It's it's an unfortunate scenario, but I don't know how to solve
Does
it.
does it a compiler error? It's not possible to compiler. No, it doesn't say it's like I would think that, if there was an unsatisfiable interface, that it would be a compilation problem, right? But it
It
doesn't
wouldn't
seem
it
like that.
it's like you're using interface, but you're using interface by specifying things so far that there's nothing that they can do. So it is just it makes no sense. I don't know if it would throw a compiler error. I've never actually tried it myself. I just read about it and I thought it was interesting that you can create constraints that are unsatisfiable. Like it's impossible that anything will ever go in here. And since that's true, that means they share nothing, which means you can only do the base interface operations, like even if it did compile,
Hmm.
which I thought was very interesting.
So, like, the lesson learned there, it seems like if you're going to, well, that's interesting. So I wonder how integers float. Oh, I see, because it's a synthesis. What I was trying to say or trying to get out was, the lesson I'm learning is I'm probably gonna put tilde in front of all these things.
So you can only put tilde in front of the built-in types. You cannot put
Oh,
tilde
is
in
that
front of your own
right?
types. Yes,
Oh,
correct.
also good to
Because
know.
the rule is that if your underlying type is yourself, then that's when you can use the comparator operators. So if you have a type and it looks at the underlying type and it is one of the base types, then you can use it. And it's only for built-in types, excluding error, because error is special.
Always.
Always. So that's another one of those gotchas. There's a lot of
I wonder if we
sharp
put that
edges.
I wonder if Paul put that on his Go aha moments page.
I don't know how much he's looked into Go. I'm sure he's looked at the spec and he probably is excited about it. But there are some interesting edges, and if you actually, I mean, I don't think I've come across a tutorial that goes through everything. But if you go through the type parameters proposal, I think it's at the bottom. Um, there's issues and oversights and things that are hard to do. Like I don't know if you've used the zero value inside of Go very often, but Go has this concept of every type has a zero value. So for custom types, if it's a pointer custom type, it's nil. That's the zero value. If it's a non-pointer type, it's the struct with all of the internal values set to their zero value. So if you have a struct that has an int inside of it, the zero value for int is zero. The date time has a special zero value called empty, which is just it's all zeros. Um,
I've
and
always
so
called it the default value, but I didn't know it was called zero value.
yeah, actually, date time actually has a function called is zero on it
Hmm.
as well, which is where I think when I was first learning Go, I said, "What is this function?" Because it just made no sense to me.
Does
I'm
it
like,
test
why
it if
would
it's zero? That's cool.
yeah? And what I
What
realized
if it's
was is that
one?
is that yeah is that what does it mean for a date time to be a default value? Like, what does that even mean? So that's how they solved it. They created a special known type for date time zeros, and they just put a function on there called is zero, and it compares, the internals to make sure they're all zero,
Yeah,
essentially.
it's better than being nil safe, and it's also better than what C# did with the nillable date time value type stuff.
Oh yeah, with the question mark in front of
Yeah,
the primitives.
yeah.
Yeah, yeah, which is great. Honestly, if it wasn't there, it would make API REST API development very
Oh, it
difficult.
was a mess back before it.
Yeah,
I
because
know I
then
was always very
you can't
annoyed.
tell. You can't tell if it was. You have to have your JSON.
1901, right? That was the default date.
Yeah,
It was just a mess.
you'd have to check your JSON parser would have to basically tell you whether or not the value was put in there or not, because you couldn't just look at the value, because it would be your default value in C sharp, but you
That's what
you
the
couldn't
epic is
tell.
for, right?
Yeah, yeah. So yeah,
1/1/1970.
yeah. So zero values are interesting. Um, there's no simple way to get zero values. Um, so you just you can try to work with it. They outline a couple of different options in here, but zero values are also like another sticking point, which it's one of
Hmm.
those little things that until you come across it, you'd be like, oh, why is this so difficult?
Yeah.
And then there's no simple expression for zero value of type parameters. So you either gotta there's a couple options here, like inside of generics, you can do type assertion. So you can actually look at this type. And so the thing you have to remember is it's not going to be, I believe what they said is it's not going to be the actual type of the thing coming in, it will be the type that satisfied the constraint. So like if you have a variable that satisfies two different interfaces, and maybe one interface is like the superset of it. So you have interface one, which is the superset, interface two, which is a subset, and the constraint is interface two. When you actually look at the type, it'll be of type interface two. It won't actually be the actual. It won't actually be the type that you want if you're trying looking for interface one, like trying to decide between those two. Like there's some weird things in there that you just have to be aware of. That like in order for Go to decide how to treat it, it had to say it was a specific type. I believe you can still take it down to the concrete, though. You can actually say, is it this specific? Is this interface implemented by this specific concrete type? But it's a whole different ballgame. Um, yeah. So one of the other things, they are adding this slice package as well. So they're adding a generic enhanced slice package, so you can sort, you can do indexing, you can have basically type safe slices instead of defining your slice every time if you would like. And so they're going to have all these cool functions on here that'll do more than just take interface in, and they're doing the same thing for map as well. So
Hmm.
those are on the docket for release. So some nice just initial, I want to learn how to do this. You can come look at these packages. It'll be in the release notes. And Go 118, they actually have them spelled out right here in the middle of the release notes. So you can just click on them and it'll take you right to it. But yeah,
Cool.
yeah. So we talked about type parameters. Type parameters are gonna they're basically the root of generic support. We didn't talk about type inference. We touched on it a few times. So basically, what type inference is there's a couple of different ways to specify a type for a generic. Let me see. For, is it? Do they not have a? Oh, I'm on the release notes. That's why it'll be in the proposal. Let's see if we can come up with find a good example. Right. So we have a map function. Let's see if we can get up and look at this. So this map function is taking in type 1 and type 2 of any right here. And so when we actually call it, when we actually call map, we're actually passing it in and we're not actually specifying the types. We're just letting it figure it out. You can actually let me see if I can find a better one. You don't have to specify it, but you can specify it. So like here's an
When
example.
you say and when you say specify it, you are meaning the input parameter?
The types of the input parameters.
Yeah,
So
right.
yeah,
Basically declaring them when you invoke the function.
it's yeah, and I can type it out faster than I could probably find it in here. So let's say if we're in our Go code, right? We're in some function, and we were going to call a generic function. It's like my generic. So if you're passing in, let's say we have like uh, we have these two guys, and we're passing them in. We're doing this. If this is a generic function, you can also specify it like this, where you actually say, I'm actually passing in 2 ints, or maybe this one is int64. You can actually say this is an int64. And so you can specify the types you want in, because what Go will do is if you don't specify these, it's going to use what's called type inference, and it's going to try to figure out what the right one is. But there are scenarios where there might be more than one right answer. You can think about a scenario where multiple types might implement multiple interfaces, which are all valid going in, because maybe the constraint is a union of three interfaces, and you implement all three of them. So which one should you be? It's just going to guess. It's going to
Mhm.
try its best to figure out which one it is. But if you're doing something inside of your function that is triggered by, say, it's actually looking at the actual type being passed in, and you're doing some kind of type assertion, you might actually need to specify the actual type you want, rather
So
than
I would
letting
I
Go
would
figure it out.
expect here Go will probably find the broadest definition and call it that. But if there were a more narrow definition that you specifically wanted that might have additional functionality, you could choose to scope it more narrowly and thus gain access to the additional functionality that's not part of the broader superset.
I have no idea which one it would choose. Like if the constraint allows multiple different interfaces, it might just choose the first one that it has that satisfies the generic function. Because Go's not going to know, if you're doing type assertion, Go's not going to know what the right answer is. It might be able to tell you, might be able to notice, oh, you're doing some kind of type assertion here, but it doesn't know, should I try to make it right for the first case or the second case? It doesn't
Right.
know. So in those scenarios, like you might actually need to specify the type you want it to go in and not use type inference. Because for syntactical sugar, like, you don't always want to be typing your types that are going there. You just want to type, call my function, I'm using generics, do the right
Figure it out.
thing,
Yeah,
figure it
right.
out. But you can construct your code in a way where it's Go will just guess, and it might be right and it might be wrong. And so that's another interesting scenario, like where if you're using type inference, you might have a bug, but because of the way the code is structured or the way the type inference system is written, it might work just fine. And then one day somebody might change Go and it might just break, and you might have no idea why. Like it could be, I don't know, it's you're using the wrong type now. That's weird. And then you just, you come in here and you just add your types in, boom, or and so these are primitives. Obviously, they're not the best. This scenario would really come up when it's like my interface or in my interface too. Something like this is more
I,
likely.
I I like a good int 65 myself.
And then 65, yeah. So this type of type inference where it does it, where you do it for you, is whenever I see this, I'm always going to wonder in someone's code. I'm like, are you just new to generics and you think it has to be there, or is there a reason?
Yeah,
Because like
you
the second I see it, I'm be like, why?
yeah. Cool.
Yeah. So that's type inference. We talked about constraints being interfaces. We also talked about the any constraint. We also talked about the packages. Talked about tilde being the approximate type like finder. Um, some things that won't change because of Go generics. Anything doing with YAML or JSON parsing. Some people think that might, but you don't really want to change how those operate because they operate by taking interfaces in. So just because something can be a generic doesn't mean it should. But they like specifically like with JSON parsing, YAML parsing. I was watching a video where they were basically saying they weren't going to change those at all because there was no reason to put
I
generics
don't know
there.
how you
So
I don't know how you could. Yeah. I mean,
yeah, it's
when you're parsing YAML or JSON and you want types, you probably have already made a struct that you want to parse that stuff into anyway.
yeah. Some other things that will change. So inside of ZD Edge, we have these things called models, and this actually, so this pattern was the pattern of having API routers for the REST API endpoints, not routers as in the network sense, but routers as in HTTP handlers. Having models and then persistence, like this fleshed out version was developed by Paul. He's also on the ZD core team, and it's actually mirrored inside of the Fabric as well. So when Fabric started to get its own more complex and advanced data model, he basically ported it from the edge to the Fabric. I wrote the initial one, which had separation between the REST layer and the business layer, but not the persistence layer. And that's something that Paul added. So that's how it ended up in this 3-tier architecture. But if we actually come into this, we can actually see in the base model. We'll just go into it real quick. So base
Don't
model,
forget to make it just a bit bigger.
yep.
Thank you.
We have these standard functions. And if we actually go into, say, CA model, this is another one. It it pretty much always implements the same stuff, but whether this can be turned into a generic or not is awkward because this code is different every time. It's like what we're actually doing with the types is different. So, and it's not logic heavy. This is just moving fields between basically data objects.
So,
This
for
is not
example, I would use generics in the past as a way on a concrete class to effectively as an interface so that I had the same functions over and over again to be implemented. So kind of like enforcing the interface, if you would, and yet still have the types available to be set. You know what I mean? So actually have the fields available and yet have the functions that I need at the same time. It doesn't sound like that's going to be too much different in Go because you already have an interface. Or am I getting it wrong?
well, even in like C sharp, they have the concept of an interface. But I think when I did C sharp for a good 5 to 7 years straight. I think most people that I worked with, they relied on generics quite heavily. and it was very rare to actually see a real interface. Like interfaces were very, very rare. And I
But, like,
remember asking myself, like, what's the point of the interface if I can just use uh, a generic?
a type, yeah. Real type with, things behind it. Like, yeah.
Yeah. And in when I was watching people talk about generics and Go, there was a sense of not doing that, a sense of wanting people to write code and not write types. So I'm interested to see where it goes, cuz
How it gets used, yeah.
yeah, because this is in my GoLand. I have interfaces and interface type names highlighted in this hot pink, so they stand out to me. So like I know this is a concrete and this is an interface, and I like that. I like to know that because it tells me, because when you're referencing something by the interface, it's always a pointer,
Mhm.
and that's interesting just for memory stuff. But um, this could be a generic, like it could be T handler over here,
Yeah. Yeah. Well, like,
but
for
but but
example,
there's no reason to do that.
like, in the past, I have created a generic data object, for example. Like that CRUD thing that you were talking about before, I would make that a generic class, and then all
Mm,
my methods, all my functions would be typed to, my CRUD would be typed to that thing. And then if I wanted a new object, I would just instantiate a new, or I would extend the generic type, and all of a sudden I give it type information, and I've got all my stuff. It was easy peasy, you know.
yeah,
Like, I could see us having generic router classes or structs, generic, memory, or not memory, database access classes, example, that sort of stuff. I could totally see that.
yeah, yeah. It really comes down to what you're doing. So if you're just passing something in to call a method on it, like we are here, it doesn't need to be a generic. It's not there's nothing about this function here that screams make this a generic to me, because nothing in here is reusable. Nothing about this logic is reusable. I think about generics as, I have logic and the type doesn't matter and I just want to do the same thing. And that's why generics apply really well to collections, because you don't really care what you're collecting. You might care that you can get an ID or a hash off of the object, but other than that it doesn't matter. You want to
Yeah,
use the same logic to always insert at the front, insert at the back. If you're sorting, you always want to sort the same way based on maybe a key. Like it's less about calling functions on the thing, because that's where interfaces really shine. It's more about, can you reuse the logic and CRUD operations. Is like if you always just put the thing in a bucket, if you're using a key value store like we are inside of Ziti Edge and Ziti Fabric, it's always the same. There's no point to care about what that type is. You might need a specific interface, to help you figure out what the key is, but you don't really care. So like the persistence layer stuff, which is in it's right underneath model and persistence, is kind of it might make it, because right now we're using base stores and they're taking in interfaces, and it works. I'm not 100% on whether or not this is actually going to be make sense as a generic. It could, because one of the things we do when we go into the CA store is I literally copy the CA store and then I basically change everything. But
alright,
there's
well,
not a lot of
I know
logic.
where to start
This
now if I wanna make my own router inside of ZT. Just find the
API
CA
router,
router.
yeah. If you want to make if you want to make a store, copy this one.
That'd be
So
sick. I love it.
yeah, but
Best
there's
practice from
not
Andrew Martinez.
it's there's not a lot of reusable logic inside of the stores. It's like, so
Yeah,
the way it's been developed by Paul over the time, and he's massaged these kind of down. Like it's basically non-shareable information. Like this,
sure.
like setting the actual properties non-shareable.
Yeah,
Um, Setting up the all of the symbols non-shareable, because it's unique to the data type,
yep,
and setting up, th- it looks like this one is doing some special stuff with their loads, but these are overridden. These are overridden just for this type because it's doing some special stuff. But all of these have already been abstracted away in from the base store, that you don't really need it uh,
makes sense.
to. So generics really don't make sense at this level, in my opinion. Model doesn't really make sense either. I think they're probably going to stay the same, but it's really at the API level where we have these CRUD operations where like it's the same code, only the types change. I think is where we're going to get the most bang for the buck. And I also
Yep.
think concurrent maps. Can't wait. Have
Right.
typed maps. It would be really great. Typed collections, really great. I am interested to see what libraries come out, because I'm sure people are going to come out with, for all the things that Go generics don't do. Like they don't allow the equal. They don't always allow the equal operator. They don't always allow less than, greater than. I'm assuming what's going to happen is people are going to come out with their own set of interfaces, and if you make your types implement their interfaces, then you can use their less than, greater than. But it's going to be like a method called dot less than, dot greater than. And I'm interested to see which libraries come out, which ones kind of float to the top, and then how Go responds, because I see that as like kind of the natural progression. This generics implementation seems like the minimum viable product for generics. And I personally thought about just going out and like gung ho writing a bunch of collection libraries just to be the collection guy, but I figured somebody else was probably already going to do it. So
Probably already out there, huh?
it's probably already out there. I just don't know where it is. They're just waiting to post about it on Reddit and Hacker News, right?
That's funny. We have a question asking if you can turn off inference or write your code in such a way to avoid ambiguity. I think you covered that though, where you were talking about adding the specific types directly to the function itself.
Yeah. To answer the question, you can do both. You are correct, Clint. You can definitely just add the types when you're calling your generic functions, or your generic types. You can actually specify them, the actual types you want to be used. So that is turning off type inference. Is saying, don't figure this out on your own. Take these, and Go
I
will do
got you.
that.
I got you. Go.
I got you. The Can you write your code so that doesn't happen? I would say yes, but since the way interfaces work in Go, you don't specify your type as being an interface. Your type becomes that interface the second you implement the interface. So you don't get to say you're not this interface or you're not that interface. You just become the interfaces you implement. So if you are really careful about every interface that is ever introduced into your system or compiled into your program, then yes, because you also have to remember your downstream dependencies that you pull in, their public interfaces that are exposed to you, that are accessible by you. Your types can implement those interfaces. So you have to be really careful about the dependencies that you're bringing in, and also all the interfaces you're writing. And so technically, yes, you could control type inference that way, but it'd be extremely difficult, especially since dependencies change all the time.
Well, Andrew, this has been fantastic. Thanks so very much for showing up to ZDTV, taking us on a tour of GoLang and some generics and seeing how we might put them into Ziti. I've enjoyed it, so thanks. And I think that'll be all for today. We're right at the top of the hour, so it's good timing. And maybe we can go back and, as Dave says, make some more bugs.
Nice. Thank you
All
for